morning, everyone, and I welcome you all for the 5 days FDP on the Artificial Intelligence and Machine Learning organized by the Department of Artificial Intelligence at Smith's Group of Educational Institution, METS School of Engineering, METS Polytechnic College, METS College of Advanced Study, METS College of Pathological Science and Research. I would like to welcome our speaker, Dr. Basavaraj Patel. Basavaraj Patel is an accomplished academic and researcher in a field of computer science engineering and specializing in the wireless multimedia sensor network and Internet of Things and cybersecurity. Holding the PhD in the Vishwaviswaraya Technological University in the Belgaum, India, he has made a significant contribution through his professional roles, including his current position as an assistant professor in the Dhyana Vidyada Sangara College of Engineering in a strength of academic background and over a decade of teaching experience. Dr. Basavaraj Patel sir has applied his experience in the various roles at the prominent institutions and contributing to the both teaching and research. In addition to his academic roles, Dr. Basavaraj Patel sir has been recognized as an innovative contributions to the research, such as securing the patent on the blockchain based on the IoT systems and AI-derived the healthcare applications. His work in the securing wireless secure sensor network and developing the IoT-based solutions reflected his commitment to advanced technologies. Dr. Basavaraj Patel sir is also actively involved in the scholar activities and demonstrated by his numerous journal publications, conference presentations, memberships in the prestigious technical organization. His accomplishment has extended to the organizing and participating in the key events and further commitment to the impact in the field. Welcome you, sir.
Thank you, madam. Thank you for your nice introduction. Madam, I'll be using two logins, one mobile and one system. Am I audible?
Yes, sir. Okay, sir. No problem, sir.
So audio will be with the mobile so that it will be having a good clarity.
Okay,
Even
sir.
if case any presentation power goes on, so that it will be available.
Okay, sir.
Yeah, madam. Let us start the session.
Yes, sir. We can start the session, sir.
Yeah, madam. Good morning, all participants and my dear colleagues, friends. So, I'm Dr. Basaraj Patil from Dayanand Sagar College of Engineering, Karnataka, which is located in Bangalore. So, in today's session, we'll be dealing about AI and machine learning using Veka tool. So, as in the previous lectures and the upcoming lectures, you'll be hearing more about AI and machine learning algorithms, how to use, how to define, what are all the possibilities are there, what all the things are required for enhancing the automation process. But my content is slightly deviated from basic fundamentals of the algorithms and remaining contents. Like I'll be going with the a tool which can be used in a simple way for applying your machine learning algorithms without any programming skills, just by understanding the algorithms. If you know how to use, what are the functionalities, how the algorithms can be used for it, it is more than enough for the design of or getting the results. We are not building the automation tools using the Veka tool, but we are analyzing the results of the given data set, where we will be able to find out how the data is available, how data is processed, how can we apply different kinds of the algorithm. So in today's presentation, my contents includes a brief overview of AI/ML, as I'm not going in detail with the AI and machine learning, as the whole session will be connected with the AI/ML, and the overview of the Veka tool. What are the functionalities? How do you demonstrate the application in real time? I'll show you the hands-on session, how the tool can be used for analyzing and getting the results, and continued with some case studies where we can apply the implementation of the Veka tool, and followed by AI trends in future, and with the conclusion. Coming up to the AI and machine learning. So nowadays in the present generation, every AI component is getting recognized and moving on through the automation process, and a lot of requirement in the industry, like everywhere, every instance of the applications are converted into the automation, where the human intervention is not required. And to think beyond the limits of the human brain, we are getting into the AI, that is artificial intelligence, which creates the decisions or which handles the scenarios based on the analysis. Whereas before getting to the AI, a human being is trained the system with different machine learning algorithms, and there are a lot many algorithms which can enable based on the applications to adapt to the given data sets. And these are basically essential patterns and requirements for the current trends, as we call it as a silicon era or a industrial technological era, where lot many industries, even not only computer science related domain industries, even a mechanical based, civil based, chemical, biotech, all domain applications are used for AI ML, where these have become like a mandatory contents for every curriculum or every part of the industry, where we can apply AI by using machine learning algorithms in every sector. In specifically, we can say in production line, to identify the loopholes, mistakes. We are going with the applications. We implement a machine learning algorithm to find out whether some every process of preparation or the product preparation is going in a smooth way, or is there any errors, any mistakes in between or somewhere else. So all every minute particles, even to find out the macro nano particles of the application, we are finding out, we are making it to get into the extent of using AI and machine learning. With respect to the machine learning, it is a again a sub branch of the machine artificial intelligence, where we say that computers are trained to behave like a human being, whereas the data has to be provided from the user or the previously existing data. In the current internet things, all the informations are put together into the cloud or some other applications, where the created data is enormous, but the using of the data is very difficult task, where we can analyze whether that data is required, whether the data is not required, how to process the data, how to follow up the data, and how to retrieve the important information from that particular application is become a good big headache. So that we have a technologies like big data, where we work on the analysis of the data to extract, to process it in a quicker manner. In that all the domains, we are using a machine learning algorithms, which will make us to analyze the data first, and then decide which data to be received or which data to be retrieved, and which to process and for required decisions. So when we consider with the process basic simple general model, I have a data. This is a data which we are using. This data will be processed. Sorry, the data will be given as an input, and we choose the type of the model, where we are considering what kind of model is required. This is the model. I can use any machine learning algorithm, where I can define, I can use initially to consider the elements. For this model, the data is given as an input, where we learn. For example, a simple common layman words we can put into that, a small kid who is getting into the first standard, will make them to learn alphabets. So the model is your language, English, or any particular language, Hindi, Kannada, Tamil, Malayalam, whatever the language you may apply. But the data is what you train. We are making our kids to say that this symbol is A. So always the kid, wherever he finds that this is a shape, he will try to match with the alphabet A. Similarly, Z. So wherever the symbols are, the contents are matching to this pattern, they will say that this is Z. So the kid is not born with the knowledge, but we are training them. So the same way, machine learning algorithms are required to train, where the data is predefined or pre-fed for the models, where the training process takes place. That is nothing but a learning phase. Once the training is done, we make use of the training model. We get the completed model, and that training model is evaluated by the test data. So as we all teachers, we know that we are teaching the students for one semester, and we are taking exams at the end. So it is of the same kind. Some questions may be within the data set, or some maybe not win the data set. That is what the testing process which happens with the applications. So every time when we provide when we provide the input to the data, we expect some required data based on the model we choose and based on the requirements which we define. So here it happens with the same process where we are getting the data as the input in either of the format. It may be CSV file, it may be any other data files, whatever the kind of the data formats we may provide as the input. Even I can give an image as an input. For example, if I give a lion or some animal image, I want to say that the given data set, you find out the number of the similar kind of the data or the lions or the count the number of lions in the image. So that can be done very easily in the huge data set. So we are dealing with the machine learning algorithm, not for the smaller data set. If it is higher data set, it is more precious and more efficient with respect to the machine learning algorithms. Then the process of training and testing. So it's a very simple concept. I have a data. This is my data, which is universal, which mixed with the different categories of the data, which are taken for training. We will segregate. Oh, these are the plus symbols. These are the circular shaped buttons symbols, which we can observe. So this data is observed and we are trained the information so that this is this kind of data is this and the other thing is this category. For example, if you have a marbles and the sticks, we can segregate marbles as one group and sticks as the others group. But in the testing phase, there will be a combination of the data. You can observe that here we have a plus as well as the circular shaped buttons, which will be a conflict, and this is the loss of efficiency in case of the not properly trained applications. So this cannot be defined at the time of designing. So this is what the a minor zero point 0.5, zero point 0.1, zero point 0.2 errors occurs in all the machine learning algorithms. Not every algorithm is suitable for every case of the application. So using this scenario like training and testing, we move on with the application so that the training will be done for the given data set and randomly selected applications are used for a testing phase. So to want to get into these all the cases, we need the algorithms. What is algorithm? It is nothing but a set of programs or the instructions which we are providing. So here in the application, we have a machine learning algorithms which are categorized into four set of types. One is supervised, the other is semi-supervised, reinforcement, and unsupervised. So I hope most of you are aware of these basic categories of the machine learning as it is most trending. In supervised learning, the intervention of the methods like we need to insist what kind of data is this, what is the category of the data. For that we can classify, we can apply the regression algorithms. There are some algorithms of the kind of classification is k nearest neighbor, SVM, decision trees. Similarly, linear regression and the logistic regressions. These are the few examples which come under the supervised machine learning types, where the data is known, the kind of the data is also known, and we are providing to process and just to classify. We know that the data set have a marbles and the state. We are categorizing them by applying this supervised learning. Whereas semi-supervised comes to that some data is known, some data is not known. What kind of data is available? We are not aware of those kind of the data in the data set which we have provided. So in such cases, we can apply semi-supervised learning. We can have a restricted Bosolman machines or deep Meridian networks kind of algorithms to get the data extracted from the given data set. And the third category we can say is a reinforcement, where an external applicant is interacting with the data set, which is referred as an agent. So we define some kind of the data where we don't know the process we will be applying through the agent so that we can retrieve the information. And the last category is unsupervised data, which will be like data is not known for us. For example, the hackers affecting or intervening the system. We are not aware of the kind of the hackers or the kind of the viruses infected to our computers or the systems. So to identify that, we are training the system with some previously known data. These are the types of the files, these are the contents, these are the patterns of the data which are infectable, or those are referred as a viruses. Those may be a different kind of harming data for the application or the system. So we train with the data which is known for us, and we test for unknown data where the data set is unknown for us, so that we can identify the anomalies in the internet, where we can identify the cyber attacks. There are a lot many opportunities for learning with the machine learning and clustering, the kind of the data which we are categorizing using k-means, dbscan, hierarchical clustering. So all these algorithms are used for the clustering and anomaly detection. We discussed about one class, SVM, and isolation forest. Similarly, dimensionality reduction. For example, we want to define a model. We have designed a model. We apply a PCA, principal component analysis technique, or a linear embedding techniques, where we have a different set of the data which are dynamically getting. Will make them to train already with the pre-existing data or pre-fed data is used for training and then analyzing the applications. And the last category of the data is the association learning. So it is one of the important aspect when we consider with the data mining and data warehouse scenarios, or the data which is processed using data mining techniques. We define with the a priori algorithm. So that algorithm is also applied as one of the type of the machine learning, where it is considered as a unsupervised learning. So by categorizing the data based on the application, we'll choose the specific algorithm so that we'll be able to get effective results. I cannot apply any kind of algorithm for all the data sets. We have some certain requirements for each kind of the algorithms, so that for that the data required has to be provided. For that the data has to be specified, the required format. If the data is inefficient or incomplete, there may be a possibility of not getting effective results. So this is all about the basic fundamentals of the machine learning. So am I followable, or any requirements, any queries still here? Participants, is it clear?
Clear, sir.
But the main intention of mine is not about going in detail with the machine learning algorithms. My intention is to make you know how the Vector tool can be used, how the data is to be analyzed, how can we process the applications in the further by using the given data set without programming skills. We don't need any programming, only we need to know what are the algorithms, for what purpose we are using, and how can we get the kind of the data for it. So that is what the requirement for us, so that we'll be able to know, able to understand the data kind which will be processed for applications. So moving on, the same category like supervised, unsupervised, we are segregating the data, and the semi-supervised learning algorithms. The structure of supervised learning, where we can provide the data with the labels. So that is very important aspect in the supervised learning. That data will be moved forward to identify the features. Those features are extracted, and based on the feature extraction process, we apply the kind of the algorithm which we use, and then we predict by applying the predictive models and get the expected data, that these are the categories of the data. For example, if you are using SVM, we categorize the data based on the kind of the data or the objects. Similarly, unsupervised learning has the structures. Again, the data is same, but there is no labeling of the data in the given input. That is a difference between supervised and unsupervised learning. Similarly, we have unsupervised, different categories of the algorithms, as we already discussed about clustering, density estimation, dimensionality reduction. The different kinds of the techniques are used for categorizing or analyzing the unsupervised data, where we don't have the labels for the particular given data set. And coming back to the main highlighting point of today's session is a Veka. So have you heard of a Weka tool? If yes, you can just say yes in the chat box so that we'll be able to know whether you have been aware of this Weka tool. Fine, no issues. We'll discuss in today's session. So basically, Weka is an application which is, you believe or not, it is a student project in the New Zealand, one of the university, where the set of students have designed the simple application to process the data that is used for data mining process. Where they have named this tool name as Veka, as this is the name of the bird in the New Zealand, which is familiar. So by considering this, they are defined with the name of the tool as Veka. And considering Veka is defined as Vekato environment for knowledge analysis. So initially, when this application is designed, their earlier intention plan was only for processing the task with the data mining techniques. So that is how they defined, they started, the students have built the application as their mini project, not as a major project, as a mini project to process the data which is available and find out the data which is required using data mining techniques. This is basically designed with the Java code and under the guidance of the faculties and these researchers from the Department of Computer Science, University of Waikato, New Zealand, they have defined it. And the one drawback of this Weka tool, before we get to know, it constrains, it has a limited data sets. It cannot analyze the data in very huge. It can limit with 500,000, 10, up to 10,000 data input values can be considered. But beyond that, the efficiency of the application get reduced. So this is one of the very well organized format where we can get extract the results in the graphical view, visual form, tree structures, and the analysis that way that by just providing the input data sets. So it is very important, like it is an open source tool. It is a data analytic method which will extract you the data from the given data set and provide you a valuable insights. If you heard of the confusion matrix in machine learning algorithms, you will get a ready confusion matrix based on the selected data set. And we also have the option to choose the number of parameters, not all the parameters together for analyzing the data. Every parameter, I want only two parameters, I can combine them, get the results. If I need more than that, I can get the results. If I want to draw the tree structure using J48 or the decision tree, I have the visibility of that. So this makes us to help and analyze the data in a very simple manner, that how the data is classified, how data is applied with the algorithm, how can we predict, what kind of algorithms are used, and what are the different data processing which are required to pre-process before classifying, before applying regression, before applying the clustering methods. We can get to know a overview of the applications. Basically, for your mini projects of the students, you can assign a topic, you give the data set from the available open source Kaggle or somewhere else, and you can provide that as a input data set and you make your students to analyze, or you collect the data of your whole organization and find out how this best the data is analyzed to find out the different set of the applications where we can analyze the results, classify the students based on the results, based on the locality, based on their abilities, based on the skills they have. For example, if you want to give a list of students for analyzing and making the students to the interested for analyzing with the a specific language or the tools, we can make use of these applications so that because the huge data, if it is around to 10,000, 15,000 data of the students, it is very difficult for us to analyze manually. Even using Excel, we can do by filtering option, but we'll be not able to get so much efficient results as compared to the machine learning algorithm, as we can also predict what is the expectation of this. And when we consider the major applications or the functionalities of the Weka tool, it is very user friendly. You believe or not, even a fifth standard student kid, if you say how to use, he can make it to provide the data and process it. So that is how it is very flexible and very user friendly, which you can provide a very good GUI interface. And the latest developments with the Weka tool is also involved in including your Python, Java, or other programming languages into it, so that you can interface your other programming languages with the Weka tool also. That is how the advantage of the tools which have been provided with the Weka tool. What is this Weka? So as we discussed, the major important features is to provide the pre-processing, learn the algorithms, is to train the algorithms and find out what are the best results, and also with the graphical interface which is very user friendly for the users, where I can compare different algorithms. I can get the data with one algorithm and I can get the analysis of the data with another algorithm. Then compare it in a Word document so that we can give a comparative analysis of all the algorithms under clustering, under classification, under other categories of the experiments where we can use for the analysis of the data using a Weka tool. So the simple concept of installation, there is no much big difficulty. If you are using Windows, you just click here because the link is already attached as a hyperlink. I'll share it to the resource person or the organizer so that they will share in turn to the students or all the participants. You can share it to your students for the data to download, or you can directly download from the internet, like where to find out the Weka tool. For Mac OS, Intel processors, we have a different file. And for ARM processor, we have a different file, so that it will be not getting any issues or the conflicts in the application. And for Linux, also we have the file where we can unzip and get installed it in a very simple manner. Like double click install in Windows, and rest of the things we need to use the commands. And one more very important aspect with respect to the Weka is you have a command line interface as well as the GUI interface. It's not only a GUI, it also have a command line where we can make our students work on the command line, write the program, write the commands to execute the applications. And that is all we can make, integrate these Weka tools into my application of other machine learning advanced applications using Python, Java, .NET, whatever the programming language we need, we can integrate them so that we can help, it will help to analyze the data. This is a user-friendly programming tool, which we can say that it is one of the simplest way to analyze the data. And for running the Weka tool, the minimum requirements for each of the versions of the Weka versions is Java. So there are versions 3.0 and earlier. So as of now, 3.8, 3.9 are the stable versions. So in the demonstration today, I'll be showing you 3.8.6, which requires Java 8, which we installed already in the system. We need to have that file. If not, it will be difficult for analyzing the information. And also we need to set the environment variables for Java as well as Weka in your computers to work on this. There are different versions which are defined for different categories. Earlier, it was some kind of a simple tool. Then it was enhanced with the like it is like the book-based application or a practical-based application. Now it has come into the development level as it is integrated with more applications and more add-on extensions are used for the Java. And you may be very aware that we have learned C programming, we learn Java, Python. Every information has a different kinds of the inputs. How do you provide the input is a different scenario. What kind of data is given as an input is another scenario. We have a data types. We have a methods to call. So similarly, we have a Java class called as Weka.core.instance. If required, if you without Weka tool, we can integrate the Weka applications or the Weka functions in your Java program using Eclipse, NetBeans, or any other Java IDEs. or even a basic fundamental data tool, which is a command line Java compiler also. It is consisting of the number of attributes. So we provide the data in the form of data sets. The input is provided as a data set, like it's not for 1, 2, 10. It is a huge data where I have 500, 600, 1,000, 10,000 data elements in it. And every data has an attribute. So like your integer data type or a float data type or a character data type, we have attributes which defines the kind of the data we are using in the application or using in the Aveka programming, Aveka tool. The one type of that is a nominal, where we say one of the data will have with the value, predefined value. For example, I want to define or identify the color of the objects in the given data set. So already we know the familiar color red, green, blue. I can specify in the method the initialization of the attributes like data sets that, yeah, madam. Any queries, madam? Okay, sorry. So if we need to provide the kind of the data, for example, int A is of the type B, sorry, A is of the type integer, which is having a specific value as an integer as an input. So in such kind of the data or such kind of the elements, we define a predefined values as a nominal attributes. So I'm speaking about the programming part where we can integrate this Veka in our programs directly by defining as a nominal type. I can define red, green, blue, green, yellow, white, red, whatever the colors we want. And the second type of the attribute we are using is numeric value. As integer, we define a numeric. It may be float, integer, or any kind of the in numbers, the decimal, without the decimal. We define that with the numeric type, and the string, which are enclosed within the double quotes. And for analyzing the data, so date is very important with respect to the data. Whenever we analyze past 10 years, this was the scenario. Next 10 years, what will be the scenario? So every time we specify the date specifically, we say this is what happened and this is what the statistics of analysis in 2020. Now this is a statistics in 2024. So in such kind of the information or the data set, we use the data type date directly, which is referred as attribute. And one more is a relation, how the data attributes are related. We need to specify how data is integrated and they are related to each other. Coming on to the format of the data. So basically, your Veka tool is given as an input with either ARFF, that is attribute relation file format, or the CSV file or the binary. So these are the kinds of the input files we can import directly from your data sets or the databases like ARF, CSV, binary. Apart from giving input as a data file, we can also include your connectivity with the SQL databases like JDBC. So all of PA familiar with compiling the application. We connect the web pages in the background with the database, that is Oracle or MySQL or whatever the other kind of SQL databases. So that facility is also integrated in the Veka tool. We can just provide the URL or the database, or I can choose the database files. We'll see these examples in the demonstration in the further scenarios. So this is how we can provide the different kinds of the data formats required for the Veka tool. So we basically specify ARFF or CSV for the analysis, because all the data will be available in the Excel format, which we save it as a ARFF or CSV files. Even a binary is a bit lesser because we'll be considering more with the CSV files, which is more familiar for everyone in every scenarios. Then moving on to understand how these data formats are represented. So when we say attribute, relation, or the data, or the kind of the attributes we are specifying, this is what the sample scenario we define with the header section, which describes what is the type of the attributes and the data section. Two are the components of my data file format in the ARFF. So initially, we consider the comments. So as we all know, comment section is very important for enhancing the data or the programs for future reusability. So we define the comments within the percentage symbol or the modular symbol. The title which we are considering is Irish plant disease database. I have a Irish data set where I'll be providing that as an input. And what is the relation which specifies the data set? The name of the data set, that is Irish. So in which I already have a samples and the different kinds of the data sets which will help for analyzing the iris, whether they are infected, whether they are not infected, whether we can segregate based on the different attributes we'll be considering. So apart from that, we have a different attributes like sepal length, sepal width, petal width. So these are the attributes of the type numeric. What is numeric? Can anybody recall and say the answer? It is an integer input data where we provide the information in the form of inputs. So that is how we make use of the applications to specify at attribute. Sepal length is the name of the parameter which we define as the element, and the kind of the attribute it is numeric. Similarly, I have a different varieties of the attributes, like we consider them as a class. I define a class Iris iotaso, Iris versicolor, and Vigenica. So these are the three kinds of the classes. This class we define for categorizing, classifying the information for the given data set. For example, how do you specify the data? So we say that at data is one of the attribute or the parameter which we are using. 5.1 comma 3.5 comma 1.4 comma 0.2, which specifies that it is a iris setosa as a value. We are defining when we are saying that in the ARF format, we specify the values and it is categorized into iris setosa. Why we need this data input? Because the data set is huge. We are providing the unformatted or formatted data with labels, without labels. So the design system has to analyze if these parameters are matching with these values, it will be providing you identifying at this particular input is iris setosa. This parameter is iris versicolor. So this is how the data is provided and given as the input. So this is the contents which we represent the ARF format in the external agents or external forms. And coming up to the next with the flat files. So we have a different data set taken here, which is a heart disease simplified. So as in most of the students in the final year, they find out what is the rate of heart disease detection, the machine learning model to identify the heart disease predictions, or predictive model to identify heart disease. So for such kind of data set, we are using the attributes age, which is of the numeric form, the gender or the sex, which is for specifying with the nominal value, then chest pain type. So we are defining the values. What kind of chest pain types are available? Angina, non-angina, or other category of angina. So we are categorizing them A type, not type. So that particular data is defined as a class, which is specified with the attributes. Then cholesterol, as we all know, the reports are provided, lab reports give you the direct value of cholesterol value. Then exercise induced angina, whether it is yes or no. Then we say whether the heart disease or any prediction is present or not present. For that, we provide the data with whether present category, not present, with the different examples. So these are the sample kind of the formats with the flat files and the data inputs, which will help us to define our own data sets. So some researchers who are pursuing PhD, they can find out or they will collect the data from the hospitals or some other research level so that they can get them data, analyze it so that they can make the data to be given in this particular format for the Vika tool. Then moving on, the practical demonstration, which is a more important aspects of the application, where we initially load the data to the Veka tool, we choose the algorithm, we interpret the results by varying the inputs, by specifying the data sets, the prediction values, the percentage of the data for training and testing. Basically, we say 70% training and 30% testing. In some applications, we need 30, 40, 50, 50% training, 50% testing, or the variance of the ratio of training and testing. And that will make us to more experienced, more practical, which will help us to demonstrate the tool. So before moving on to the live tool, I'll just go through the slides. I've taken the screenshots of the applications where you overview or analyze the use of the tool on the parameters which are available so that we can proceed it to the practical things in a easier manner. So I have collected some snapshots. So this is our main graphical user interface, which provides program menu, visualization tools, and the help menu, but the main concentration is on these applications. What are these applications? How they are helpful for my data, my information, how they are much important for my analysis. So the first kind is Explorer. So the name says the very important, like Explorer helps us to analyze the data, to explore the kind of the data. We are applying the algorithm, we are making the analysis, getting the analysis report. We are not making any additional improvements or additional application where we need to choose or we need to specify. We are not making it to happen like what new things can be done. Only the part of the role of explorer is we'll give an input for the given data set, which will be analyzing for the given data input. The second important category is the experimenter. So this is very important for the researchers where we can experiment by varying the models. We can design the pattern. We can design the models. What will be the input? What kind of algorithm you want? You just provide the input that will be proceeded and further recognized for the information. And the third one is knowledge flow. Knowledge flow is like I'm designing the new architecture of the machine learning model where I have a mindset, I have a plan or the proposal like this means the first block, second block, third block, how the data has to be inputted, pre-processed, and then applied with the different algorithms and parallelly get the different kinds of the results. So we can make it to happen with our own interface where we can design our new process model. That is what the most important and the learning things in the knowledge flow. And the fourth category is workbench. It is like we know what we happens in the machine learning. We take the input, we pre-process, we classify, we make it in a clustering group, we experiment, we process and evaluate. So that will be helpful for the Veka tool, which will be required for me to analyze the data with a given application. And the last part is very important, the command line interface. For the young programmers, we are not providing the direct graphical user interface so that they will not learn the programming commands or the programming skills in an effective way. Basically, when I'll be handling the classes for related to programming, C, C++, Java, Python, I suggest the a command line interface so that they can by heart or they can remember, recall with the practice what is the command used to analyze, compile the program, analyze it so that they can proceed with the understanding of the command line interface. As computer science domain experts, we need to be good enough in the Linux based command line interface so that it will be helpful. all the ways we cannot go for a proprietorship or license based graphical user interfaces which are not free like your Vika tool, which is freely available as an open source. Nowadays, Microsoft has a big Microsoft Visual Studio, which is costlier for the licensed version. Similarly, the other tools which are very difficult for making the purchasing of the license. So, and one more thing, there may be a drawbacks of the interventions of the application, some errors, viruses, whereas open source are open for the development, enhancements, and all other requirements for understanding. Then moving on to choose the first parameter as an explorer. I'll just quickly move with the slide so that I'll go for the practical demonstration of the tool. Explorer, the first option. So as I mentioned, we are using the version 3.8.6, which is a stable version. We have a version of 3.9, but we need, we are expecting the 3.8.6 is a somewhat stable with the experimentation. Then moving on to the application, can you observe this preprocessor, classify, cluster, associate, selected attributes, visualize? So I have taken just a zoom up application window of it, where I can first initially start with the pre-process step. I have an option to open the file, which is already existing, give a URL link, or open database, or generate your own dataset. Instantly, I can generate the dataset based on my needs. Then choose the kind of the algorithm, choose the kind of the algorithm, apply the pre-processing tools or the techniques, which we call it as a filters, like discretization, normalization, resampling, selection of the attributes, transforming, and the combination of the attributes can be done for the pre-processing phase by selecting the data in the various formats. So I have been demonstrating here with the ARFF format. Then comes to the classification, where the machine learning algorithms or data mining algorithms like decision tree, A48, those help us to classify the kind of the data, and we can also represent in the tree structure or the tree format where the data to be classified in the different manner, like this as an example. So I have a simple data. Will you read this section? So this is my data. I want to apply a classification technique for this. If I say yes, I will say move on to the next question. Will you understand it? If I read this section and understand it, then we'll be able to learn it. A simple outcome. If the scenario is yes, the next level is yes, then I will be saying yes, the student or the reader is understood with the content. This is how the tree structure is categorized, whether the user is reading the section or not reading the section. For example, when you are using the browser applications or some trial versions of the tools like your chat GPT or all other things, somehow you use or not, after 3 days, the application will not allow you to use it back because they are using the machine learning techniques which will analyze whether you use, whether you apply or not, it will be closed on that particular day. And some applications are there, these many number of hours or this is this much of the data you can analyze. For example, you have a free space of 10 GB or 10 MB as a simple example. Until 10 MB, your application works. Whether you use today, tomorrow, after 1 year, you can use that data for till the completion of the allotted resources. So that is how you can analyze the users, whether they are using the applications regularly or not. And even the emails are categorized. For example, if you click a subscription application for some of the forums, TechBuzz or some other forums, they'll be sending you every day with the news, whatever the things new are in the industry or what new things on particular domain. It's like a news bulletin you'll be getting daily, 2 days once, or weekly once, or quarterly. And one fine day after 1 month, you will get a message like whether uh, the dear user, you are not opened the email from last 1 week or 1 month. So do you confirm whether you want to continue the subscription or not? So how the machine will understand that you have not opened the email of the particular domain, not specifically all emails. You have not opened the email sent by that particular organization or the news bulletin, whether you read it or not. So that they can understand by the machine. So we can apply the classification techniques so that I can analyze, I can understand whether I read the message, I read the email or not. A simple example which we use very familiar in our WhatsApp message. You have one single tick and second tick and the third one is a blue tick. How the blue ticks will be applicable? How you display it? So it is again a machine learning technique. If the user has read the message, then only you will get a blue tick. So the application will classify the message whether the user has read. If you open it, the screen or the message is red, then only you'll be able to get a double blue tick. Otherwise, you'll not able to get. It will be only a white colored or your dark colored lights, not with the blue tick. So this is how we can apply in real time with the classification. We have a model construction, model usage, which are predefined. We label. Without labels, we proceed and we make it apply for the classifications. And moving on with the next category of the kinds of the classification. We have a Navy Bayes algorithm, BaseNet algorithm, decision trees, under which J48 random tree, which will be given as a common inputs, which is a nominal or a numeric values, which will take the data, it will classify and provide you the results like what is the expected results, what kind of data is provided, whether they are suitable, whether they are not suitable, even the categorization of the skill sets of the students for interviews. We can maintain a common Excel sheet where the student are specifying their skill sets which they learn, the tools they understood, they undergone the certification courses. When the company asks you the student data, I want the students with C++ background. You just apply your machine learning technique, choose the method, shortlist your students, and give the data set easily for the placement of office or placement team so that they can proceed for considering them for the interviews. Then moving on, decision making based on the kind of the data we are specifying. It is a decision tree which will be helping us to classify the data by splitting the given input training data sets. And further, we can apply different kinds of the data where we can generate, and we know every application has advantage and the disadvantages. Considering the decision trees, we have advantages easy to understand, easy to generate, whereas overfitting of the data cannot be suitable, partitioning is not easy. For large data, it is not easier for analyzing, and it's not so simple to make the analysis in a simpler way, like compared to the other reflective algorithms and the decision tree. Then we have a classifiers like Navy Bayes classifier, where we want to classify based on the classes we specify, what kind of dependencies are there, whether it is not dependent. We'll make it to specify that they are classified in the different types. It also have the advantages, easy to train, faster, but assume that independency of the feature should be available for the Navy Bayes. So these are the different kinds of the techniques. Then moving on to the clustering. Clustering is grouping the elements of the similar kind and segregating the dissimilar objects. It's a simple object where I segregate based on the color, shape, pattern, design, or the type of the data to just to so that intercluster distance are minimum to find out what is the distance of the maximized data. Then the different applications like marketing, insurance, earthquake, libraries, ordering the books, organizing them. We can apply the clustering, grouping the books based on the categories of the department. So it is very easy for the developers, users, not for the developers. It is easy for the users to apply, use the applications based on the machine learning techniques. So, some of the commonly used machine learning clustering techniques are k-means, fuzzy c-means, hierarchical clustering, and a mixture of Gaussian techniques. So, these are much familiar and usable for most of the applications in general, where they provide their abilities, stable content, so that they are much important, much better for the providing with effective results. Before moving on to the case studies, we'll just go on with a demonstration. Will it be fine, ma'am?
Yes, sir.
Yeah, I'll just directly go with the demonstration so that everyone will get to know how to use the tool directly, because that is very important for analyzing. I'll just reshare my window for whole window.
Yes, sir.
I'm sharing my entire screen so that everyone is visible with the contents. So I'll just scroll down with the Veka tool. So I find the queries are there. So we'll be addressing at the later stage. So it will be easy for finishing my presentation. So it may reflect with the multiple windows. So it's not an issue, but I need to represent with the Veka tool. Is it visible, madam?
Yes, sir.
Yeah. Just I have installed the version of 3.8.6 Veka tool. So we can observe that Veka 3.8.6 is application. We also have a console which is a command prompt. So this is what the symbol which we are getting with the Veka environment. Madam, any queries? Rama, madam? Madam, can anyone mute Rama, madam? It is.
Yes, sir. Muted, sir.
Yeah, madam. Thank you. So this is a Veka application. I'll just maximize my window. So this is the window graphical user interface of the Veka tool, which is being developed by Waikato University, New Zealand. Moving on first with the Explorer. We'll start with the Explorer application. How can we choose the data set? So no need to worry about the basic data set training. Already the application itself have the data. Here, this is the window GUI interface, which will be explored for the Veka, where I need to, excuse me, Rama madam. So we have the files. To select the file, as I have shown the image, we can select the file which is already existing. It may be of the any format. I can open the URL by specifying where the data is available, and database connectivity I can also do. I can generate my own data. First, I'll show how to generate the artificial data. Then I'll move on to the actual data set. So this is what the data generator operation. I can choose the kind of the algorithms which are available for classification as well as clustering. So I will choose a random forest or RF, random RBF, and I'll say generate. I'll click on generate option. Can you see the data which is already available? I got 10 parameters along with the elements so that I'll be able to select all the data and the graphs are already visualizable. So I can click, I can just check it the data. The visibility of all the data sets are available for just given input. It's a simple concept. I not applied any filtering. So these are all the A1, A2, A0, all 10 elements. Whatever the data we are seeing here, A0, A1, A2, we'll be able to visualize all the graphs based on the type of the data, the categorization. All attributes are displayed. If I'm able to filter, I can filter that by clicking on the filter, supervise, attributes, attribute selection. I can select only few attributes so that I can get only that particular category of the data. I selected 1, 2, 3, 4, 5, 6. So I'll be able to get only all those based on the categorization. Based on the class which I define, I will be able to visualize. So this is how it helps for analyzing the data by specifying the class by considering the elements. If I apply, only two classes are selected, and for that, I'll be able to visualize. I selected only two attributes, A0 and A1. So only for two of them are displayed with the data. This is how we can generate the data and we can use. I can also edit the generated data. Where I have created my data, I can edit. So this is what the classes which are defined, numeric and the nominal data elements. This is the input file where 100 elements are generated automatically, where I can edit that. I can add the instance, I can create the instance, I can modify the values. So I can make it 0. So I can make the other categories and then make it OK. So the data will be updated for me. So this is how we can generate for trial testing purpose what kind of data are required. And in order to get or choose the specific values, I'll just remove this data element which are generated. So I will select the new file where the data is already available, the ARF files. Just want to select the application where we have used, where we have defined. Just a minute, I'll close the window and start again with the Explorer. So now I need to choose the input instance. Already in the download section, means in the Windows C program, wherever the application is installed, in the program files, we have a Weka tool which is installed. Just a minute, getting error now. Program data. Just one window back. The complete path has to be given so that the formats of the file should be in the ARFF format only. Otherwise, it will not be able to select the data. I'll move on to the other file format.
എത്ര എന്തെങ്കിലും ഉണ്ട് ആ സാർ പൂജാ നോൻപ് വിദ്യാരം
I have a Vika demonstration. It's not allowing to take the file directly. In just a minute, I'll show you the presentation screenshots which are already taken. It's not loading the data set. I don't know the error. What the only thing you need to open the file, you need to move on to the data. I've taken all the screenshots step by step for analyzing and understanding the process, training it. So it will help us to go through the slides. We have another slide. So here we have a step-by-step representation for the Veka. The slide is moving, madam. Can you confirm?
yes sir it is within sir.
Yeah, madam. Under the Explorer, it is considered as a pre-processing stage. So you can observe that I want to select the new file so that the data set is chosen where iris data set which has the attributes sepal length, sepal width, petal width and the class. So based on this, we are categorizing or the automatic graphical representations are visible. As I shown, if you click on this visual all, you will get all kind of the graphs which can be directly added into your research articles. So then moving on, by specifying the class, there are three categories of the classes: Iris setosa, Iris vesicolor, and Iris vaginica. So what are the number of parameters or the counts available? The data elements related to all these classes, 50, 50, 50. So we have 150 data elements, instances, which are categorized 50, 50, 50. And then moving on to visualize all, as I said, I will categorize all the data set based on the sepal length, sepal width, petal width, and the classes. Madam, whether my slides are visible?
Sir just now it has been stopped sir.
Just a minute, madam. It is one of the drawbacks with the online sessions. Just a minute, it's reloading the browser. I don't know what happened. I'll just connect it back 2 minutes. In the meanwhile, whether the contents are clear for all,
Yes, sir.
you can understand the flow of the contents, the planned objectives to reach that, to understand what is Veka, how to make that to use for machine learning.
Yes, sir. Got some idea.
Yeah, madam. Nice. Just a minute, madam. There is some restarting of the browser happened. I'll let you know.
Okay, sir.
Yeah, madam.
बड़ा बड़ा कट्टी है ना ಇಲ್ಲ ಕಟ್ಟಿ Sir, please unmute, sir.
Madam, can you give some 2 minutes of time? I'll change the browser. The share button is getting invisible, means it's not active.
Okay, okay, sir.
I'll share the different browser so that I can get.
Okay, sir.
Yeah. Madam, am I visible with the slides? New.
Yes, sir.
Yeah, madam. Thank you. I changed the browser so that we can get into it. As lot many people are joining to the Google Meet, it is making me difficult for getting into the things. So here I have taken the screenshots of the earlier version on the MacBook, not on the Windows. I'm just showing you the demonstration of the images, which is same as on your present new application also. So here we have selected 150 set instances of the Iris dataset, which will help us to analyze and get the data with the different categories of the information, which will be like 30 categories of, means 50 categories of different three classes, which we already discussed. Then we apply the filter. You can see the option of the filter here. This filter option are available with unsupervised attributes, instances, and recently with different categories of the information, which will help us to choose the kind of the attribute, that is whether we need to add the noise, remove the cluster, convert the numeric data to the binary. All other different categories of the data will be chosen. So this is what my pre-processing stage in my machine learning technique, which will be specified. Then I click on apply so that my data will be, excuse me, my data will be specified with that particular pre-processing stage. Then moving on, by selecting the parameters, number of bins, how many number of bins I need to choose, and find the number bins, whether it is true or false. So we can set these values, click save, and then OK. Then specify equal frequency or not. It depends on the kind of the application we are performing. We can see the changes here. The false value we have shifted to true. Then click OK. Moving on, it will be specifying the type of the filter. It is only the filter. It is not the algorithm. It is only the filter we are applying. Then we say, so this is what the data is categorized, classified based on the petal length. If I click on sepal length, the data will be categorized. Then further moving on for the classifiers, every classifier algorithms are being specified, whether you use the training data set to specify or to test, or you use supply a separate data set for the testing, or use a cross validation like 10 folds, or use a percentage split like 66 for training and remaining for the testing. What kind of operation you are applying for the classification of the data set? I need to choose the kind of the classifier like zero R, bias, navy bias. There are different categories of the classifiers which are already built on the Veka tool. We can just choose the kind of the algorithm. It's a classifier algorithm which will get you to select and classify the data based on that. I have chosen 48, J48 as one of the classifier, and then set the values so that whether to use the different categories of the say the instances, number of folds, all these specific object editors can be done by clicking on this particular window, so that you'll be able to specify the different functionalities based on your requirements. When you are making a research paper, you have to consider different attributes for different factors. So you can change the values, you can record the data and store in the tabular form, so that you'll be able to get. And I want to split the data based on 66 percentage for the test and the train. Based on that, we can choose the different operations. How do you set? What kind of predictions? Whether you want to store the visualization. For example, I want to classify the elements in the tree format or the visual form. Whether to store it, whether to store the predictions with the visual form, that I need to choose. Select OK. Then click on Start. So once you start, you'll get the data. You can see the information like what kind of schema is applied, what is the data set or the relation, the number of instances, number of attributes used, 66 for training, and remainder whatever the content, that is 34 for the testing purpose. That is what we call as the 66 percentage or for the test purpose, means we train. So based on the methods, we got the values like the number of leaves with reference to the SS set also is 5. So this is my final results of the number of leaves. So moving on, I'll just scroll it down. The time taken is also recorded, the number of seconds, and the complete evaluation results. We have 150 set of the data, in which 49 are effectively, means out of 50, 49 are correctly classified instances and 2 are incorrect. The 96% of the efficiency is correct and 3.9% is with the error. Keeping with the statistics, we calculate with the mean absolute error value is 39, that is 0.39. The root mean square error value is calculated 0.15. Relative absolute error is also given, it is 8.89. Relative squared error is also given, that is 33 percentage. And total number of instances which are considered are 51. Based on these classification of J48 algorithm, true positive rate is 0.98 for each of these classes. False positive rate is 0 and 0 for Setosa and Vajinica. It is only 0.06 for Iris versicolor. The precision values are also calculated based on each class. Recall value is also calculated. F mean square value is also measured. And also your confusion matrix is also generated for the given categories. A, B, C are referred as iris setosa, iris versicolor, and iris vaginica. So this is what the statistics will be able to get for all set of the information, whatever the based on the algorithms. So is this clear with the classification? Can I get the messages of the thumbs up symbols in the chat so that I can move forward for the next category of the cluster? Thank you. Thank you very much for the response. So this is how, because when you say that doing this manually, writing the program in Java, Python, C, C++, it takes hundreds of lines of the data and we'll be not able to know whether the data is accurate, results are effective, properly received or evaluated. By these tools, it makes the researchers to find out what is my expected data, what is my results, how can I enhance this J48 algorithm for the next level or next kind of the data sets. So that is what the advantage with the use of these latest trending tools. Moving on, we can just visualize this tree structure by right click on this. I have a different options. I want to visualize the tree, how this data set has been classified, and this is how the data is also ready. So we get the ready-made food, like ready-made data, like the classification of the values based on the sepal width, where as well as sepal length for each of the data sets which we have specified. And it will categorize whether it is vesicon, vegicana, or the other set as well. So this is what the tree structure which is readily available for the visualization. So this is the most advantageous application. And we can also find out the errors. We can plot the graphs by just by right clicking the visualize classifier errors. If you click on this particular option, we'll be able to get the window where x-axis, y-axis can be chosen based on your requirement. I can choose any x-axis which are available with the data. I can click on these individual. I can say x-axis. I can choose any of these so that I can get fully visualization based on the elements. Here, the blue color icons or the symbols represent for the Cetaceau, Iris Cetaceau dataset, red for versicolor, and green for Vigenica. So this is how we predict, we categorize, we classify the data into the different forms by the number of instances. I can also choose the different algorithm. I'm going to choose with another example, neural network. The data set, I'll start with the classification. So this is my neural network data which have been classified and how they are related. The window, then when I click on this start, I will get the statistics. So you can see the statistics based on the test plate, the confusion matrix, true positive rate. So all other things will be able to get again for Navy Bass. I can proceed for the same way. I can get the results for each of the algorithms so that I can compare. I can say what is a true positive rate for each of the data algorithm for the same data sets by considering the same percentage of the data plates for testing and training. So we can visualize the threshold curve for the Navy base in this format. So I can choose what is the threshold form. I can choose the y-axis, true positive, false positive rates. So here it makes the researchers to get or create a survey paper in an easier manner by taking these plots, and you can mention in the acknowledgement that where we use the Veka tool for the analysis. This is what the existing algorithms provide the results, and this is what I have enhanced. I have modified the existing algorithm to design my own research algorithm. This is the best research analysis or the literature survey tool where we can get the results directly from the applications. Similarly, I can form the tree structures, data visualizer based on the segmentation, classification, change the color. So this is what the data to be analyzed in a different manner. So I'll quickly move on to the cluster group because lot many algorithms I have taken screenshots. I'll share all these contents if required, or you can say that I'll give the website link. You can download it from it. I'll be uploading it. Moving on to the clustering of the data. Again, k-means algorithm, x-means, fuzzy C. The different kinds of the algorithms are there. So this menu, the third menu in the Explorer cluster, where I will choose the algorithm which is required for clustering. Simple K means, X means, the same process continues. Classes based on the classification or the clustering based on the classification. So this is what the data I will be able to get. I can scroll, I can say first cluster is versicolor and the second cluster is setosa. As the other one, Viginica, is not falling under any category, which is incorrectly classified. 50 sets. So 33% of the accuracy is incorrect. So remaining 66% of the data is accurate for clustering. So this is what the clustering algorithms we can use. I can also visualize the tree, the number of nodes, 150 instances, out of which 96 are true, properly classified, and 54 are not classified properly, or the categorization. Clustering assignments, again, we can visualize the graphical way, the representation for the windows, means for the given input. And finding the association, as we know, in most of, if you are handled with the data mining subject for your students, or if you are learned, you'll be able to know the person who have purchased the milk, butter, he has a 70% of probability of purchasing the bread and the eggs. So predicting the association which are connected with the learning. So how to we are using a priori algorithm. For that, we have a concept a priori. We'll choose the data set first by selecting the appropriate associate algorithm. This is a priori. Before choosing this associate, we have to go back to the preprocessor where I need to choose the attributes. Here we have the chosen voting, the votes, the number of users vote who are having more than age based on the different categories. That data is chosen for associate techniques, and this is the results we'll be able to get once we specify the person, the probability of the purchasing of a particular product who have purchased some other product. Based on that, we'll be able to classify associate rules. Then moving on with the selection of the attributes, like select the specific attributes based on the values. I'll just skip on these things. The kind of the ranker technique you can apply, best first, forward selection, race search, generic genetic search, random search, exhaustive search, rank search, or the ranker. Any kind of the attribute selection technique can be chosen so that you can apply for the given data sets. You can get the classifications, ranking of the attributes as the results, which is the first, which is the next. And the last part in the Explorer is visualization. Am I going very fast or is it convenient to understand? Yeah, thank you. I'm just moving on because lot many things. I don't want to skip any of the part with the Veka components or the applications. So when we move with the visualization, I have chosen the element, the data set as a glass. Then the number of instances are 214. I will classify based on the type of the data glass is manufactured with. So these are the set of the attributes which we are specifying, which we are considering. With the minimum data sets, the number of distinct instances are 178 and the unique instances are 145. So this help us to understand. So for testing with the different algorithms, by making these attributes as a common parameter, I can get the results in a different manner. So I have taken, this is the visualization for RI, the visualization for NA, the type of the elements based on the glass categorization. I can visualize. If I click on one of the window, I will be able to get the full kind of the elements. I can change the visualization plot size, plot point size, the jitter value by selecting the different attributes. This is how I can make the visualization in a much better way. So as we are the researchers, we want to publish the papers in the high quality journals. So there, the only explaining the content is not enough to justify your results. If you plot the data with these kind of the tools which are available, it will be more attractive and the chances of getting the selection scrutinized for the publication will be higher in the percentage rates. So one more categories of the classification considering x-axis, y-axis. Based on that, how do you choose the data forms? The graphical representations are same, but the techniques methods are different. So I can choose the instance I want to categorize, classify, choose in this particular window the type of the data. What are the highlighted parts? So submit so that I can visualize only that particular part in the extent exhaustive zoom manner so that the data is readily available for the classification. This particular part, which I have been showing with the rectangle, that I can move anywhere and that particular part will get me the visualization of that particular sector or the region of interest which I have chosen. You can see the value of x-axis from 1.05 to 1.49, whereas it was initially 0.29 to 3.5. Means selecting the region of interest in the graph. Even in the Excel, we'll be not able to get this kind of the zooming of the application. It is very difficult to plot the graphs of this kind. I can easily plot, I can zoom in so that my data is not having any issues. I can get the exact good amount of contents which is visible. And this is all about the explorer part. Moving on to the experiment, the another application in the Veka, which will help us to conduct the experiments. So when I click on experiment, I'll be getting this window, whether I want to configure in a simple way or with the advanced one. So that is how we'll be able to choose the elements, whether it is a simple kind of experiment we want to perform or advanced. I can create the new experiment or I can open the existing. I can choose the results with the database. I can make the cross validation or based on the number of folds, whether I classify using classification algorithm or regression algorithm. What are the data sets I am using? Whether I am using a relative data set, what are the number of repetitions I want to use, and what kind of algorithm I need to choose for my experiment. So all these parameters can be chosen by selecting the new. I want to choose the new. I'll define the new data set, that is by specifying the stored or the available data set. I use the cross validation technique with the number of folds as 10 with the classification, and I'll start with the run. Once I start run, I'll be able to get, I should be able to get, there were zero errors. That is what your application to be compiled in a proper way. Then I'll be moving on to the analyze mode, and then I'll be selecting the file which is already existing, which I got the result experimented. So that experimented, whatever the results I just chosen by J48, this is my experimented results. I have chosen iris data, I have chosen vote data, I have taken glass data for J48 for functionality and bias. Three different kinds of the algorithms. My experiment is providing me these kind of the results. Which is better, which is good, which is required for each of the data set. You are the one who can choose the different experiments based on the parameters. We can also perform the different kinds of the test. I can save the test for the further usage. So here, by this experiment, we have got 900 results. The previous selected, whichever the setup we have done here, this particular previous slide, this experiment where we have created, for that we have chosen three different data sets. We have chosen three different algorithms which will be making me to get analysis of these results. So any queries, sir? Let me know the queries with respect to this. Or let me finish with the contents. So moving on to the next part, the third model or the application which is available is the knowledge flow GUI interface. So in the knowledge flow, we'll be getting this kind of window, and each of the components represent different entity, where initially we start with the evaluation process. We plot the experiments in the order, then we visualize, then we filter, we classify. These are the different operations that can be performed with my new set of experiments. First, I'll go on with the data source, the initial step. I will choose the kind of the data which I need to get an input, whether you want ARFF file or you want CSV file, C45 file, or other kinds of the files. So I have chosen ARFF. Click here and drag so that I'll get ARFF loader. Then I will choose the classifier. I'll use a data visualizer for the data. Then I will select, right click on this window. You can choose the data set of your choice. That is what the configuration you will be able to do for each of the application. Once you choose the data set, you can start loading the data to be loaded and establish a connection between the data set and the visualizer by selecting the points or to point, so that I can give this data as a visualization. I can right click and get the data. So you can continue this for selecting all these elements. And the final, I have selected iris data set. I have used cross validation data fold. I am using testing attribute selection. I used SMO for classifier. And for the given data set, I use the data visualizer, attribute summarizer, CLAD plotter, and for the SMO results, I'm using the evaluation parameter like classifier, performance evaluator, and finally visualize with the text viewer. So this is what the number of elements or the components I have chosen from this particular environment. I can save this experiment using save button in the corner, or if I already created an environment or experiment, I can open using this particular symbol with the open. And when I compile the results, start loading, configure, save, start loading. The show the once I start load, all the data will be processed, or it will pass on with all the phases, and the results will be finally available in the last module. That is the test viewer, where I will right click on that, show the results. So this is my results for the given selected experiment. For the given data set, 144 correctly selected data out of 150. So 96% of the correct instance. 6 data are not classified properly. That is incorrect. I'll be able to get 4%. Again, root mean score error value, absolute error, total number of instances, proper root square relative errors 58%. This is what the text visualization will be able to get. Then I can plot the graph for this for the accuracy under the category of the strip chart. So you can see the another example, ARF loader, where I have taken a IFBK as one of the instance of the visualizer. Then I have chosen a classifier evaluator, and in strip chart, I'll be able to get the different kinds of the graphs. So already in the classifier, all these elements are available. I'm not defining anything new. I'm not designing anything new. Already they are available. Just drag and drop, learn what is all these algorithms, what are the classifiers used, and then select them and apply. So this is what the experiment applications which will be able to get based on my contents. Coming on to the case studies. So we can use in most of the applications predictive maintenance in manufacturing to identify the earlier detection of the failures. We are using these cases in the wildlife protection. They just listed some of the examples where I can provide, explore this with the Veka tool by considering the data set of production management, life, wildlife and creatures, and healthcare applications. To enhance with this, what are the latest AI trends in 2024? Data utilization is the most required. Audio vision models, because earlier we had just have experimental sessions like a given input with a data form. We design a model that will get me to understand the visualization. No, nowadays it is not as enough with only data. We need to consider a data, videos, models so that I can get the better results. And in turn, we have a built with large scale models, large language models, LLMs, which will enhancing our reinforcement algorithms. And we also have our hyper automations tools like RPA, robotic process automation, which automate anywhere. UiPath are the companies where they are making the process automate. So we can apply there for the trends as a new categories. And what is the future of AI and ML with the Veka? Promising future, advanced automation, multimodal AI, adaptability, and ease of integration of the data, which are getting us more advanced, more effective, more better utilized for the applications. And these are the few references which we have referred for the application. So that will be helping us to understand. This is the website of the organization where the application has been built, University of Waikato. This is another web page which is connected with the library of the content. The Weka page in GitHub, the GitHub repository officially, then the IBM where we have some libraries for developers. And this is one of the latest blog or the page which I have referred for understanding machine learning algorithms to overview. So any queries? So in order to conclude, I have gone through the different phases, applications of the Veka tool and how it is applicable for the application which we are using in the basic data analysis or the algorithms. So any queries? I'm open up for the questions. Madam?
Sir?
Yeah. Any queries in the chat box, madam?
Participants, dear professors, any queries? Shall we wind up the classes? Okay, so thank you so much, sir. It was a very wonderful session, and your demo is also very effective, sir.
I'm sorry for not, the tool is not selecting and not working. That's why I already have a backup for that so that I can use that for the demonstration also.
Really, it was very useful, sir. Your demo class is very perfect, and we can able to understand that, sir. We are getting good feedback from the participants, sir.
Thank you, all the participants. My contact details are available on the slides, so you can refer to it. You'll be you are free to contact me on my webpage, sites.google.com. I have all the materials to be uploading immediately after the session. All the data is available for you. So for any queries, you are free to contact, communicate with respect to the data with make Veka usage. So can I get any one or two feedback from the or what you understood from the participants so that I can prolong with a new sessions, another session. I can improvise or I can incorporate anything which I have missed out in these 2 hours of session. Any volunteer participants, they can give their feedback in one or two lines so that it will be helpful for my next ventures or the next sessions. Thank you.
Hi, sir. Myself, Manasa. This session was very useful for us, and the tool you told discussed about here is very useful for representing graphs. For representing graphs, I think this tool is very much important. And thank you, sir, for this wonderful session. Okay, thank you.
Thank you, madam. It's not just for representing the graphs, it is analyzing the data by the given data set, madam.
That I understand that
Yeah.
is, and it plot a very beautiful graph.
Yeah, very
The
beautiful
beautiful
graphs are
graph.
available. So we can directly take a copy of it and publish in the papers. It will
Papers.
get a
Okay.
good impact.
Yes, 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 sir.
Thank you, Manasa, madam. Anyone else? If you have
Sir,
any. Yeah, madam.
sir, I'm Dr. Nitasi Olaiden.
Yeah, madam.
Actually, I was doing all these using Python.
Yeah, madam.
Okay, sir. So I found this tool very useful.
Thank you, madam. What happens in Python, we need to write code for existing work. So
Yes.
when we are performing any research, if you are when you are undergoing the PhD, we also faced many issues. So when we are going with the PhD research, existing results has to be compared with my new model. For that, I have to build the existing results once again with the programming skills. These kind of tools helps us to reduce the time of building for the existing tools, getting the results readily, and so that it is easy for comparing with the new tools.
Yes, sir. Yes,
Yeah,
it's
madam.
very useful compared to Python.
Yes, madam. Thank you, madam. Thank you, Nita, madam.
Thank you, sir.
Organizers, can I able to get the recorded video link of this after that to my email or the WhatsApp?
Yes, sir, sure, sir.
Yeah, madam. Thank you. Thank you, all the participants. This was a wonderful thing to share my knowledge with all the participants. I'm very happy. 120 plus participants were available. So I am happy that 100 plus people are effective with sharing my knowledge. Thank you, all the participants and the organizers. I also thank my college for providing my opportunity to make this happen with the things. You can take note of my contact and email ID. You are free to contact, communicate. You can follow me on LinkedIn and all other social pages so that it will help to build a network for us as well as you to publish the papers, to communicate. And in your colleges, if you are hosting any sessions, I'll be available with any many other tools as we are helping the others to learn with the new beginners. You can take a screenshot of this page so it will be helpful for contacting. Thank you all. Thank you, the organizers, for a wonderful opportunity for making me to share my knowledge to the all the people who are around all the places of the India.
Thank you, sir.
I would
Thank
like
you.
to thank Dr. Basavaraj Patel, sir, for having a wonderful session and spending a valuable time with us and accepting our invitations with one word. Thank you, sir, and having a wonderful session, sir.
Thank you, madam. Thank you.
So, dear professors, feedback link has been attached in the text box, message box. So, have a look. Or will be sending through the email by evening 7 p.m. Thank you all. You can leave the session. Tomorrow also we can join in same link. Thank you all.